Let's go through tips and tricks for binomial theorem or binomial expansion. So we know the formula for binomial expansion. The first trick for binomial expansion is, let us go through tips and tricks for binomial theorem. There are multiple tricks. Trick number 1, to get an easy and quick way of binomial expansion. Let's take this example, 2 plus root 3. So this is the first number, this is the second number, power is 6, that is n is 6. So what we are going to do is, we will first write first term, 2, second term, root 3. Then 2, root 3. N is equal to 6, which means we will have 7 terms. So we will write the 7 times. 2 into root 3. 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 So we will be writing it 7 times. 1, 2, 3, 4, 5, 6, 7. Right? Now we will have to write this NCR. N is 6. So we will write 6C. 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 Now we will have to write the R values. So it will be 0, right? 6, 0, 1, 2, 3, 4, 5, 6. Now we will have to write the first term's powers. This will also start with 6. 6. It will keep on decreasing 1 by 1. 5, 4, 3, 2, 1 and 0. The second term, it will start with 0. 0, 1, 2, 3, 4, 5, 6. Now we'll have to put plus in between. So normally if we use the formula, this formula, and keep using r is equal to 0 to r is equal to n, for a power of 6, right, it will easily take 2 to 2.5 minutes. If you go step by step, start using r is equal to 0, r is equal to 1, r is equal to 2. If you start doing that, it will easily take 2 to 2.5 minutes. But if you are using this method, it will just take 45 seconds or maybe even lesser. With practice, it might even be lesser, right? So this is, I'm telling, with an average speed, not with the high speed. With average speed, you can, within 45 seconds to 50 seconds, you can have the binomial expansion ready. Now trick number 2. Trick 2. This is a very important one. How am I going to calculate these binomial coefficients? These are binomial coefficients, that is 61, 62, 63. How am I going to calculate each of this? Now, first trick is the first term, that is the first term, and last term is always going to be 1. First term and last term is going to be 1, right? Second term is always going to be the power itself, the number which is a power. So 61 will be 6 in this case, right? Now what we are going to do, in the reverse direction, we will write 6. Second one is 6, the last second one is 6. Now, how do we calculate the third value, which is 6C2? For that we will have to calculate it. 6C2 is 6 factorial by 6 minus 2 factorial into 2 factorial, right? So this is 6 factorial by 4 factorial into 2 factorial. Now let's remember to use this trick. We'll only expand till 4 factorial because we have 4 factorial in the denominator. Why we'll do that? So that this one, the 4 factorial here and 4 factorial in the denominator will get cancelled. And then we are left with 2 factorial. We'll expand it. It will be 2 into 1. And this will get cancelled. Right? So always remember one thing. Let's not do the multiplication first. Let's always try to do the division or cancelling first. Otherwise the number is going to become huge and unnecessary. We are going to spend time in calculating it. Now this makes it simplified. Right? So we get 15 as the answer. Right? This is trick 3. Trick 3 is basically on how you can simplify the combination calculation. Now let's come to the main trick. Trick 2 as to how to find this the combination values. So we know 6C2 is 15. So what we are going to do, we are going to write 15 here. Now let's come in the reverse direction. We have 1, we have 6. Now we will put 15 here. Now we'll have to calculate the next term, which is 6C3. 6C3 is 6 factorial by 6 minus 3 factorial into 3 factorial, which is 6 factorial into 3 factorial into 3 factorial. We will expand it till 3 factorial so that we can cancel both of this, and then we are left with another 3 factorial. We'll expand it and then we'll cancel it. We'll expand it and then we will cancel it. So we are going to get 20 here. So 6C3 is 20. Let's write 20 here. So we have finished the calculation of all NCRs. So we have 7 terms, but we have only calculated for 2 terms, 62 and 63. Remaining else we have just copied, right? So this is again this will save easily another 2 to 3 minutes of time. So to summarize, whatever NCR combinations or NCR values that we get in the first terms, the first set of terms, will be repeated in the last set of terms in the reverse direction. So we have 1, 6, 15, 20, and then 15, 6, 1. So you see this 1, 6, 15, 1, 6, 15. This is in the reverse direction.